5-4 solving compound inequalities and. Essential question, what are the three types of graphs that may represent a compound and inequality? A compound inequality is two or more inequalities joined by the words and or. And you're going to see in all the examples in this lesson the word and or the word or. An intersection means where two inequalities overlap, or in our Venn diagram, where do these circles overlap? They overlap in the middle. Okay, so we're going to give you two hypothetical real world situations to help you figure out what the word and means. So to ride without a car seat, a child must be at least 8 years old and at least 57 inches tall. What is the significance of the word and? So we need to shade the intersection of the two sets. They have to be greater than or equal to 8 and greater than or equal to 57 inches. They can't be one or the other. So we're just going to shade in the middle because the only part of a Venn diagram that means it's true for both sides is if you shade in the middle. If I had just shaded the left circle or just shaded the right circle, that wouldn't be true because it has to be both of them. To be eligible for the presidency of the United States, a person must be an American-born citizen and at least 35 years of age. So if I'm American-born and I'm 35 or older, for both things to be true, the middle would need to be shaded of my Venn diagram. All right, let's get to the first example. The first type is an interval graph. I'm going to graph the two inequalities, x is greater than 1 and x is less than or equal to 5. Then I'm going to graph the two of them on the third number line. The first two number lines should be a review for you. The third one will be new. So my first step is figuring out what I want to number my number lines. I'm always going to look at what numbers are in my answers for my inequalities, 1 and 5. So I'm going to have each one of my number lines go from 1 to 5. You always want all three number lines stacked on top of each other, and you do need to have 3 of them. You want all of your numbers lined up. So all of my 1s are lined up, 2s are lined up, 3s, 4s, and 5s. All right, so my first one, x is greater than 1. I need an open circle. The x is on the left, so I can shade which way the arrow is pointing, which is to the right. I extend my line a long ways because I know everything bigger than 1 is a solution to x is greater than 1. X is less than or equal to 5. Closed circle on 5. X is on the left, so I can make my arrow, which is pointing to the left. For your third graph, your first step is always going to be take your circle from the top line, which was on 1, and the second line, which was 5, and make those 2 dots. Now I have to figure out where I need to shade. I need to figure out which numbers are shaded on both the top graph and the middle graph. So let's look here. 2 is shaded on both of them, so I'm going to put a dot at 2. 3 is shaded on both of them, so I'm going to put a dot at 3. And 4 is shaded on both of them, so I'm going to put a dot at 4. So I'm going to connect everything in between 1 and 5. Now the reason why 1 has an open circle is because it's not shaded on the top graph, but it is on the middle one. It has to be shaded on both of them in order to work. So that's why it's an open circle. We're not including that point. 2, 3, 4, and then 5 is closed because it is shaded on both the top graph and the middle graph. So that one ends up being shaded and is a solution set. So if you think about what this means, the numbers that are bigger than 1 and less than or equal to 5 are 2, 3, 4, and 5. One other thing that might help you is if you want to, I can use this trick of sliding down my graphs, and then I can see, oh, Yep, right in the middle there between 1 and 5 is where all of my solutions fall. All right, next one. This time we have x is greater than -1 and x is greater than or equal to 3. So I'm going to start out by labeling my number lines. So I'm going to go from -1 to 3 on all three number lines. -1, 0, 1, 2, and 3. -1, 0, 1, 2, and 3. -1, 0, 1, 2, and 3. So my first one is x is greater than -1. So I'm going to shade to the right with an open circle. X is greater than or equal to 3, closed circle, also shaded to the right. So now in my third graph, I'm going to put both of my circles, -1 and 3. Now keep in mind, this is our second type, which is array. That's going to give us a hint of what our graph is going to look like. If you go back a page, type 1 was our interval graph, so where are they overlapping? An interval graph looks exactly like this. So now knowing that this one is called array, we're going to end up with a array for our third graph. Now I have to look at what numbers are shaded on the top number line and the middle number line. So -1 isn't shaded on either of them. 0 is shaded on the top one but not the middle one. 1 is shaded on the top one but not the middle one. 2 is shaded on the top one but not the middle one. 3 is my first number that's shaded on both of them. So I'm going to go from my closed dot. 4 is shaded on both. 5 is shaded on both. 6 is shaded on both, and so on. So really, I don't need this green dot on -1. I'm not doing anything with it. My array starts from 3 and goes to the right. So numbers that are greater than -1 and greater than or equal to 3 are numbers that are 3 or bigger. It has to be shaded on both number lines, not just one of them. All right, x is greater than 6 and x is less than 2. This third type is called an empty set. So I need my numbers to go from 2 to 6. 2, 3. And remember again, I want all my number lines to line up, stacked exactly on top of each other. That's what makes the overlapping the easiest, is when you can visually see what numbers are shaded on both of your graphs. Okay, x is greater than 6. X is less than 2. So if I put both of my circles on 2 and 6, I have to figure out which numbers are shaded on both graphs, the top one and the middle one. Well, the numbers shaded on the top graph are 7, 8, 9, 10, 11, 12, and so on. The numbers shaded on the middle graph are 1, 0, -1, -2, -3. So none of those numbers end up being repeated. None of them are shaded on the top and the bottom, because on the top is 7 and bigger, and the middle is 1 and smaller. So there are no numbers that are both bigger than 6 and smaller than 2, so we're going to write empty set. And if you think about that logically, can you have a number that's smaller than 2 and bigger than 6? No, you can't. So the answer to that one is empty set. All right, now we need to solve and graph. So we have a little more work on this one, because we've got to solve our inequalities before we graph them. And you'll notice it doesn't tell us on this problem what kind of type we have, so we're just going to have to figure that out on our own. So couple and third wheel, 5x is my couple, so -1 on both sides. Divide both sides by 5 to break up my couple, and I'm left with x is less than or equal to 1. So that's my first inequality. My second inequality, couple is 3x, so get rid of my third wheel, add 7 to both sides. 3x is greater than or equal to 12. Divide by 3. X is greater than or equal to 4. So there is my second inequality. So that means I need my number lines to go from 1 to 4. So we'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so if I graph the top one, x is less than or equal to 1, and x is greater than or equal to 4. So now I've got to look at what numbers are shaded on both number lines. Well, my top number line has numbers that are 1 and smaller. My middle number line has numbers that are 4 and bigger. So if you think about it, you can't have a number that's less than or equal to 1 and greater than or equal to 4. So my answer for this one is empty set. There are not any numbers that are shaded on both number lines. Summary. The three types of graphs that may represent a compound and inequality are